Now another example on meeting of three equilibrium line forces at a point. We have a uniform rod of length 130 centimeter and weight 26 Newton is suspended at its ends by two strings tied at one point. So we have a rod of 130 centimeter. It's suspended at its two ends by two strings that meet at a point. If the length of one of the two strings is 50 centimeter and the length of the other is 120 centimeters, one string is 50 centimeter and the other string is 120 centimeters. What is the position in which the rod is in equilibrium? Position means an angle. So to find the position of the rod, we need the angles between the rod and the two strings. So we need angle A or theta 1 and angle B or theta 2. And also the tension in each of the two strings. So we need to find the tension in the two strings and the two angles between the rod and the two strings. The two lines of action of the tensions in the two strings are meeting at a point. So the line of action of the weight has to pass through the same point. So just extend the line of action of the force to meet the point of intersection of the two strings C. We are given the side lengths of triangle ABC. Let's compare the squares of the sides of the triangle to identify its type. Let's start by the longest side or AB, which is 130 squared. Check the sum of the squares of the other two sides of the triangle. So 50 squared and plus 120 squared. So plus 120 squared. Calculate and compare. The two sides are equal. So the triangle is a right triangle. The hypotenuse is the longest side or AB. It's right at C. So C is a right angle. From the geometry of the shape, we can easily find sine of angle A or sine of theta 1. So sine of theta 1 equals the opposite of angle A over the hypotenuse. The side opposite to angle A is BC. So sine of A or sine of theta 1 equals BC over the hypotenuse AB. So BC over the hypotenuse AB. BC is 120 over the hypotenuse is 130 to be equal to 12 over 13. This is sine theta 1. To find theta 2, let's find sine theta 2. The opposite to angle B, which is AC or 50 over the hypotenuse, which is AB or 130. So this is equal to AC over AB or equal to 50 over 130. So sine theta 2 is 5 over 13. We can use Lami's rule to find the tension in the two strings. From the geometry of the shape, here in triangle ABC, this is the right triangle at C. The weight is applied on the midpoint of the rod. So D is the midpoint of AB. AB is a right triangle at C. So CG is the median of the right triangle. The median of the right triangle equals half the length of the hypotenuse. So CD equals half of AB or equals AD and equals DB. So here we have two isosceles triangles, triangle CDA. This is an isosceles triangle, so this angle equals to this. So this is also theta 1 equals to this. Similarly, in triangle BDC, this is an isosceles triangle because DC equals DB. So here we have two equal angles. So this angle equals to angle B or equals theta 2. Now extend the line of action of the vertical weight to pass through the meeting point of the tension in the two strings, T1 and T2. Remember Lami's rule. If three forces meeting at a point are in equilibrium, so the magnitude of each force is proportional to the sine of the angle between the other two forces. From the geometry of the shape, these two angles are vertically opposite angles, so they are equal. So this is theta 1 and this is also theta 1. And similarly, here we have another pair of vertical opposite angles. So this equals to this equals to theta 2. So this angle is theta 2 and this is theta 1. The angle between T1 and the vertical weight is this angle. This is equal to 180 minus theta 2. Sine 180 minus theta 2 equals sine theta 2. Similarly, the angle between T2 and the vertical weight is this angle. This is equal to 180 minus theta 1. So this is 180 minus theta 1. And sine 180 minus theta 1 equals sine theta 1. The angle between T1 and T2 is this angle. These two angles are equal because they are vertically opposite angles. So this is a right angle. Applying Lami's rule, T1 over the angle over sine the angle between the weight and T2. So T1 over sine of theta 1 equals T2 over the sine of the angle between T1 and the force, which is 180 minus theta 2 or sine theta 2. So T2 over sine theta 2. This is equal to the weight 26 over sine of the angle between T1 and T2, which is right angle. So over sine of 90, which is 1. Now simplify. Sine theta 1 is 12 over 13. Sine theta 2 is 5 over 13. Substitute. So T1 over 12 over 13 equals T2 over sine of theta 2, which is 5 over 13. This equals 26 over sine 90 to be 26 over 1 or 26. To find T1, cross product, move 12 over 13 up. So 12 over 13 times 26 to be 24 Newton. And to get T2, move 5 over 13 up. So 5 over 13 times 26 to be 10 Newton.